In this lesson, we're talking about finding derivatives of natural logs. So the only case where you're going to use the rule for natural logs is whenever you have a natural log in your function. So whenever f of x equals the natural log of u. And so keep in mind here, u could represent any type of function. So we're using that variable just to denote that if we have a function whose independent variable maybe is x, we could substitute whatever is inside the natural log for the variable u, and the derivative is going to work out really nicely. So let's see what the rule says. If I have f of x equals natural log u, f prime of x is equal to u prime divided by u, where u is greater than 0. So all we're doing here is we're taking the derivative of what's inside the natural log, in this case u, so the derivative of u is u prime, and then we divide it by exactly what's inside the natural log. Keep in mind that the derivative does not have a natural log in the answer. So your derivative f prime of x is not going to contain the natural logarithm. If we look at a graph, what I have here is we have the function y equals natural log x, and that's going to be the graph that you see in green. And then y prime equals 1 over x whenever x is greater than 0. That's our derivative of natural log. And so what this is doing is it's measuring all of the slopes of all of the tangent lines of the natural log function. And so what you'll see is that this graph does not exist to the left of the y-axis, and that's because natural log is undefined over there. The reason being is the natural logarithm is the inverse of the function e to the x, and e to the x has a horizontal tangent at y equals 0. Therefore, our natural logarithm is going to have a vertical asymptote at x equals 0. So this is a derivative and its function, natural log x, and its derivative 1 over x. Let's look at a few examples. Say we take something like f of x equals natural log of x. So to find the derivative, it's a very simple one. We take the derivative of what's inside the natural log. The derivative of x is 1. And then we divide it by what's inside the natural log. So in this case, x. We just need to tack on the stipulation whenever x is greater than 0. Okay, let's look at g of x equals natural log of sine x. So g prime of x, I take the derivative of what's inside. So the derivative of inside of sine x is cosine. Excuse me, that's the derivative of what's inside the natural log. So derivative of sine is cosine. And then I divide it by sine x. Okay, so whenever I look at my derivative here, I'm going to end up with the cotangent function. So g prime of x is equal to cotangent x, and this is going to be whenever my values of x are greater than 0. Okay, if I look at y equals natural log of x squared plus 3, so my derivative here, dy dx, is going to be the derivative of what's inside, so 2x, divided by what's inside, so x squared plus 3. And in this case, this is going to be whenever my function is greater than 0. So I need to make sure that it's whenever my domain, x squared plus 3 is greater than 0. So in this case, it looks like my function's domain is more than likely always going to be greater than 0, because anytime I square a function, I'm always going to get a positive. So it's not going to make sense to have to include the stipulation on this particular function. So this is natural log derivative and how it works. You're simply taking the derivative of what's inside the natural log and then dividing by what's inside the natural log.